All right, everybody, welcome back to our Python primer for student researchers. And today what we're going to look at is something called conditional statements and loops. These are how we handle program flow in programming using Python. You'll find conditional statements and loops look pretty much the same in nearly every programming language. Python has its own particular syntax, but we're going to look at those today. To make it a little fun and to help us kind of see how these work, what I'm going to do is we're going to use a package called VPython. So VPython allows us to manipulate three-dimensional objects in virtual space. And the really cool thing about this is that all of that overhead for manipulating the objects kind of comes for free. So we don't have to program any of that up. So we're going to use the VPython so you can visually see what's happening, but we're going to use this to demonstrate our control program. So the first thing you want to do is install VPython if you don't have it installed already. So what we're going to do is we're going to start by looking in our Environments tab and checking for VPython under the installed packages. And I have it installed in here, but if you don't find it there, you can check to see where if it's in the not installed package. Probably won't be there because it doesn't come pre-installed even in the not installed packages. So we're going to need to run a command in our terminal to make sure that we get this downloaded properly. So we're going to go ahead and start Jupyter Notebooks. And by the way, this process works the same for both Mac and Windows and Linux as well. So if you start Jupyter Notebook, you can go over to the tab under New and open up a terminal. And once you have that, you just type conda install -c VPython space VPython, hit return, and it will analyze your system and make sure that you have everything you need to install it. So on my system here, once it's done collecting all the packages, I just need to do an update, and it'll ask me if I'm interested in doing that. If you're installing it for the first time, it may give you a bunch of other options, and you'll want to go through and just install every package and all of its dependencies. Once you've done that, exit out of Jupyter Notebook and quit Anaconda Navigator and restart it, and you should be good to go. Okay, so I'm going to go ahead and I'm going to say new. There's a VPython notebook. I'm going to go ahead and say new Python 3, however, because then I can control how I import my VPython. So I'm going to say from VPython import star. Now that's kind of a heavy-handed way of importing all those libraries, but I want to have access to these ahead of time so that I don't have to preface them with anything. And it just makes it easier because there's lots of places where I'm going to be calling things out of VPython. So this tells me to import everything from VPython so I can access it. And just to give you a quick example of how this works, I can create something called a sphere and put parentheses around it and hit return. And what that's going to do is that's going to pop up a window here that gives me a three-dimensional object that's a sphere. Now, what this has done is this has drawn a sphere on a black background. The sphere has 3 dimensions, and it's even put in lighting and shadows and all sorts of things. And if I go over here with my mouse, if I use the mouse wheel, I can zoom in and out. So you can see that that's a 3-dimensional object. And I can, by right-clicking, I can pan around, right? So you can see that what we're seeing here is a fully 3-dimensional object. And there's even lights that are making that so that's easy to see. So that's a really cool feature. And there are things that we can do to the sphere to change its properties. For example, I can change its color, turn it into a green sphere. I can change its size. I can change by changing its radius. We're not going to see anything. We're only going to see something change because it drew a second sphere, which has a radius of 20. The first had a default radius of 1. So that's the objects we're going to be using for this to see how this simulation works. So we're going to go back to the beginning here and import a new notebook, and I'm going to create our ball falling down onto a floor. So I'm going to start by saying that the ball is equal to a sphere. So it's going to draw a sphere for me. And this initial sphere, I'm going to set its position using a vector. Vector is the notation that VPython uses to handle its 3-dimensional values. It's a special data type that it has. And I'm going to put that at 10 meters above above the floor. So the first position is the X position. The second position is the Y position. So that's our left, right, and up, down. And then the third position is the back and forth in the screen there. And I'm going to set this color equal to green. And then I'm also going to put a floor in here. So if I say floor, I'm going to make this a box, and this box is going to have a size, and that size is going to be another vector, and it's going to be 20 meters by 0.1 meters thick by 20 meters. So it's going to be 20 meters in the X direction, just a tenth of a meter in the Y direction, and then 20 meters in the Z direction. And I can go ahead and draw those, and what I should get, floor and a ball, right? So this is a nice little three-dimensional scene with the floor and the ball. Now, if you've made an error in these things and you're having trouble getting this drawn, sometimes it's necessary to restart the kernel if things get a little confused. So if things aren't working the way you want, you can come up to kernel and you can hit shutdown and restart to put this back in a state where it should be able to draw this. Okay, so this is what we have. We've got our ball, we have our floor. So we'd like to simulate this ball falling from its current position onto the floor. So I'm going to do that by creating my little physical model. So I'm going to give it gravity. So this is where I put my physics in here. I'm going to give it an initial velocity, which is 0. And then what we're going to do is we're going to be stepping this through time, right? So I'm going to have to give it a time step, and I'm going to give it a time step of a tenth of a second. So that means that every tenth of a second, I'm going to be doing this calculation. And actually, let's make it 100th of a second just so we get to go a little bit more slowly there. And then what we're going to do is we're going to let this ball bounce a certain number of times. So I'm going to set this variable called bounce equal to 0. And what we're going to do is increment that n bounce variable every time it hits the floor using some conditional statements. Okay, so now what I'd like to do is I'd like to have this ball drop and bounce a certain number of times. So I'm going to use a while loop for that. And Python uses a while loop to indicate that it should execute the following code until this whatever statement is in here is no longer true. So I'm going to say n bounce is less than or equal to 10. So what that's going to do then is that when n bounce becomes greater than 10, it's going to stop this while loop. Now, whenever I do a loop, I have to indent in. That's how we know that we're in the loop. And then it's going to execute every single one of these functions. So in VPython, we put in a rate to set the display rate of the screen. This is going to make it go at a rate that we can see what's happening. Otherwise, the computer will calculate it too quickly. I'm then going to calculate the new velocity from the acceleration. So I say velocity is equal to velocity plus gravity times d time. So what this is doing is it's saying take the old value of the velocity, which starts at 0, add to it my gravity times my time step, and then set that equal to the new velocity. And then I'm going to change the ball's position too. So I'm going to say ball.pos.y. So that's saying take the y component of the vector of the position, and I'm going to set that equal to ball.pos.y plus the velocity times dt. So just like this calculation above, it says take the velocity that we just calculated, figure out how that's going to change the position, and then reset the value of the position to the new value. Now we have to check for the bounce. And for that, I'm going to use a conditional statement. I can say if the ball.pos.y is less than or equal to 0, so that is when it gets down to that 0 point, put in a colon here. And again, I have to tab in to know that I'm in the loop. I need to make this bounce. And by bounce, we just mean that momentum is conserved, so the velocity is going to be reversed. So we're coming down with a velocity. We're going to take the negative of that to go up. Because we're falling down, we're taking a negative velocity that turns into a positive velocity. And then I'm going to count the number of bounces. So that means I'm going to increment my n bounce parameter by 1. So what this while statement is doing is it's just saying while we're less than 10 number of bounces, we're going to simulate this ball falling. We're computing the velocity from the acceleration, the position from the velocity, and then we're going to check to see if we're bouncing. So what this should do when I execute this is we should be able to see this ball drop down, bounce, and go back up 10 times. Let's see what happens here. And there it goes. So you can see the ball bouncing up and down, and it's going to do that 10 times, and then it's going to stop. I lost count. There we go. Okay. And there it's going to stop at the last bounce. So that last little bit is not very realistic, but it does give you a sense of what's going on. So the other thing you can do is, now this is a completely physically realistic model for a bouncing ball that has that doesn't lose any energy, which of course means not a terribly physically realistic example. So you can modify your condition down here to change the velocity depending on how much energy it loses. So you could put in a calculation here on the conservation of energy and say it loses 10% of the energy every time. So that would be the same thing as saying reducing this by a certain percentage. So let's just take this and say, let's say the velocity gets reduced by 0.85% every single time. I don't know how physically realistic that is, but it's easy for this demonstration. Go ahead and run the code again. What's happened here? I need to redefine the positions. Okay, so there we go. So this created a new ball, but now you're going to watch this ball bounce up and down, and it went slower and slower and slower until it stopped. Let's see if we can get that to do that again. There we go. So you'll notice that it goes up a smaller amount every single time. And so it winds up at that point, it bounces to the point where it has no energy and it falls down and stays at rest. Okay, so that gives you an introduction to a couple of things. It gives you an introduction to VPython, so you can see how to create little scenes that you can manipulate. If you go to vpython.org, you'll find all sorts of information about that. And it also shows you, at least introduces in a fun way, conditional programming using while loops and if statements. And we're going to do some more of those a little bit later in the course. So we'll see you later.